Okay, good afternoon, everybody. Welcome to our webinar on multi-echelon inventory optimization. I'll shortly introduce myself. My name is Bram Desmet. I'm the Managing Director of Solventure, and we host this webinar in collaboration with our partner, MEIO UK. What do we have as agenda? I want to shortly introduce who we are and what we do as Solventure. Then I see that in a lot of companies there's a lot of pressure to reduce inventory. So let's revisit in the first place, why do we need inventory? Then I want to explain the difference between single echelon and multi-echelon inventory optimization, give some more detailed explanations on how we optimize safety stocks in the multi-echelon supply chain. Then my colleague Sven also will give a short demo of how we have implemented that in the Archiva software. I want to spend 5 minutes on showing that multi-echelon optimization is not only about safety stocks, but it also applies to lot sizes and to cycle stocks. And we want to finish this webinar with some of our experiences in implementing multi-echelon and what are some of the key challenges we see that companies are facing, and then give you the time to post some questions, and that will make for a busy hour and a heavy hour. So let's get started. Who are we as Solventure? This is a busy slide, so I will try to explain step by step. Let's start on the top left. So as Solventures, we are experts in sales, inventory, and operations planning. So we implement the SIOP process in companies. And as the circle shows, we combine different aspects when we do that. So first of all, we have good process knowledge, which means that we know how to set up a forecasting process regardless of the tooling. That's a type of expertise that our consultants have. We also strongly believe that if you really want to improve SIOP, you need to do it in combination with a tool. It's not something which you can manage just by Excel. You need decent tooling to support your SIOP process. And we use the Archiva software as Solventure. And Archiva, you can see it on the bottom right. Well, Archiva has been started by people coming from DuPont. They have been around since '93. They are headquartered in Wilmington, Delaware. They have offices in Belgium and in India. We as Solventure, we are based in Belgium, but together with Archiva, we support global SIOP implementations for industrial production companies. Next to the process and tooling knowledge, our consultants also have a very good analytics knowledge. Just to give examples, when it comes to forecasting, you have something like statistical forecasting. When it comes to inventory optimization, you can run into more advanced modeling like the multi-echelon modeling we will discuss today. If you go into planning, you can use linear programming to optimize plans. All of this is a specific type of analytics capabilities that a good SIOP consultant needs to have. And the last component here is the people component. Well, it's simple. You can have the best process, the best tool, and the most clever algorithms, but if the planner is not trusting the system, he will not use it and he will revert to his Excel solution. The blue blocks here try to give an overview of the different steps we see in an S&OP process. We start with segmenting customers and products. What we see is that many companies still use the same service level for all customers and for all products, and that's clearly wrong, because two customers are not equal. They don't have the equal volume, they don't have the equal margin, they are not equally willing to innovate with you as a supplier. So you should differentiate between customers, you should differentiate between products, and that customer product segmentation is an input to the other steps in the SIOP process. Just to give an example, if you know which are the A customers, then in your demand planning process, these customers, you probably want to start collaborative forecasting, right? So that's the first step, segmentation. Second step, product management review. Just to give another example, there the key point is to involve product managers into the broader SIOP cycle. Challenges we see there is that if you look at new product introductions, NPIs, we see that 7 out of 10 NPIs are overstated. Meaning that business cases are inflated, MOQs will be too high, and it means that you will need a quick feedback loop with the product managers to adjust NPI forecasts on the one hand downwards, on the other hand also upwards, right? So if 7 out of 10 are overstated and 3 out of 10 are understated, and there you have a service risk. Second element in the product management review is that we are very good at introducing new products, but we are very bad at taking old stuff out. And salespeople typically resist, because if you reduce the product portfolio, they will lose turnover. And how do you turn that around? Well, the principle we use there, for instance, is not just look at turnover, but also look at what is the margin that we generate and what's the inventory that is required to realize that margin. And typically by the end of the product life cycle, margins are being reduced and you need more inventory. So basically there's less bang for the buck. And all of these modules are being supported by the Arqiva software. So next steps would be demand planning or forecasting, which is probably more well known. Inventory review. So in September we will have a webinar on inventory optimization. Today we will really drill down on a more advanced type of inventory optimization, which is multi-echelon. We do supply planning at different levels of detail, so day-to-day scheduling, master planning, monthly bucket, rough cut planning on the S&OP horizon. We also roll that up into the executive SIOP meeting, so we help our customers to implement the executive S&OP meeting and to make sure that, okay, we for instance have the right type of scenario management to get them involved. And make sure that we're not only talking volumes, that we are also talking value. So volume and value, scenario management, aggregation, disaggregation, these are key differentiators from the Arqiva software compared to other softwares we have seen in the market. We will send you the slides afterwards. This is just, let's say, the same process where we more clearly define which modules the Arqiva software has available to support that broader SIOP process. These are some example customers. So as Solventure, we try to be active in different sectors, and we are primarily driven by that SIOP expertise, you could say. We do two different types of projects. So on the one hand, we are the channel partner of Arqiva into Europe. So if you think about selecting an S&OP solution, we are happy to participate with the Arqiva software. On the other hand, we also do what we call analytics as a service project. So we see that customers are not always ready to buy a software. Well, we also lease the software to companies and combine that with consulting to make sure that we can improve supply chain processes, for instance, with Arqiva as an intermediate solution in the cloud. That was it for the introduction of Solventure. For each of the blocks that I've just discussed, we will host a webinar. We also have webinar recordings already available. We are also compiling vision papers, so if you would have interest in some of the topics which we covered earlier, don't hesitate to reach out to us. But the topic for today is inventory optimization. So why do we need inventory? This seems an obvious question, but I see that many companies struggle with that. And this chart shows 5 basic layers of inventory. First is cycle stock, which is linked to our production of ordering frequency. If I produce only once a month, then I will carry on average 2 weeks of inventory. If I produce once every 2 weeks, then I will carry on average 1 week of inventory. And the lean philosophy says, okay, you need to go to a one-piece flow. So basically you want to avoid cycle stock altogether. But let's face reality, in a lot of companies we have significant changeover or ordering costs towards supplier, and as long as we have those, we will face cycle stocks. Safety stocks, so these are there to cover for uncertainty. So that's the famous K times square root lead time times sigma demand. So we try to model demand uncertainty, and we try to come up with a statistical model which allows us to couple the level of the safety stock to a certain service level. If I'm planning based on a forecast, my safety stock should be based on the forecast adder instead of the demand variability. And in that safety stock you can also add components like lead time variability. So if my average lead time is 2 weeks, but it can also be 2.5 weeks or 3 weeks. So that lead time variability is something you can account for. You can also account for volume variability, like I have asked for 100, but sometimes I receive 105, sometimes I receive only 95, and that can be due to yield or that can be due to quality issues. All these uncertainties we typically try to account for in the safety stock. Anticipation stock, a typical example there would be that if I know that I will have a shutdown because there's a holiday period, or a shutdown because I need to do a maintenance, well, typically I will anticipate and I will pre-build some inventory. That's another reason why we hold inventory. That's anticipation stock. In process transit stock, so if I ship product from Asia into Europe or the US and I do it by boat, I know that I will have significant in-transit stock. If I have long production lead times where some product needs to be curing in an oven for a couple of weeks, and that will also create in-process or work in process. That's also part of the inventory. And then we have something like strategic stock. A typical example there could be like, if I expect a certain shortage in the market, either of raw materials, either of finished product, I may decide to keep some strategic stock. What's the difference with anticipation stock? Well, for a strategic stock, we typically say, I'm not sure that the shortage will actually occur. So you can see that more as a risk management stock, where the anticipation stock is really planning for a known and certain event. And when we explain this to customers, typically we get a lot of questions on what is the exact definition. But don't get hung up with these five. These five are typically a starting point. Like if you say, well, I'm in retail, and if I do my calculation of my inventory parameters, maybe I say ideally I would have only 5 pieces on stock in a certain shop, but 5 pieces just makes for an empty shelf. So in practice, instead of 5 pieces, I need to have 20 pieces. Well, that might be another driver of inventory, that you just need to put more inventory to have a full shelf, and only a full shelf will allow you to sell stuff. Well, any driver of inventory is something that you need to put in here, because what you are basically trying to clarify here is, I see in a lot of companies that we see huge swings in inventory, and the inventory raises with 20 or 25%, and companies don't really have an explanation on why did our inventory increase with 20 or 25%? Well, the only way to know that reason is to be more specific on what are the drivers of my inventory, and knowing the drivers and making them visible will also help you in getting a better control of your inventories. This is still what we would call a single echelon view. Here we are mainly looking at one stocking point. And if we take this to a multi-echelon view, the example I used in my PhD research, and which I'll also use here, is the battery supply chain. So this is more a multi-echelon production distribution network. We are manufacturing and packaging batteries. So if we take a look, what do we need to manufacture the batteries? Well, we will need to buy components, EMDs, sponsing, separators, and so on. We use these to manufacture batteries in bulk. These bulk batteries are then packaged into 3 variants. You can see per 3, per 6, and per 9. What do I need for the packaging operation? Well, I need packaging material, and I will need bulk batteries. And as soon as I have packaged my batteries, typically in my central DC, I will then send them to 3 regional DCs, 1 east, 1 central, 1 west. So I really keep inventories here at different levels or at different echelons. And this is an interesting case. Why? Because there are distribution aspects and there are assembly aspects. And if you can solve this type of network, you can basically solve any type of network. And well, if we link the graph I've shown previously with the 5 main drivers of inventory to this type of multi-echelon network, what we are really seeing or getting is something like this, where we say, well, I have 2 dimensions. On the one hand, we already explained that there are different reasons to keep inventory. There are safety stocks, cycle stocks, pipeline stocks, build-up stocks or anticipation stocks. We can keep strategic stocks. And I can keep these at different echelons in the supply chain. So I can keep that at the regional DC level. I can keep that at the central DC level. I can have inventory of intermediates, I can have inventories of raw materials and components. And what multi-echelon inventory optimization really tries to do is to optimize these inventories across the different echelons in the supply chain. What we will focus on here in this presentation is, well, how do we optimize safety stocks across the multiple echelons? And I also want to briefly touch on how do I optimize lot sizes or cycle stocks across multiple echelons in the supply chain. Let's start with the safety stock optimization. An example I typically use, and we will play a little game here, and I will ask Cedric to help me, is this simulation game. And it takes a quite typical supply chain, and where we say I have production in Asia, I import the goods into Europe, and Europe could as well be the US. I import them into a central distribution center, which is called the European Distribution Center, or the EDC, which is somewhere centrally located in Europe, which could be Brussels. And then I have 4 regional distribution centers, RDCs, which are being replenished from the EDC. So that's also what you see here. So I import into the EDC, and the EDC replenishes the 4 regional DCs. I see the lead times here. So the lead time to import from Asia into Europe is 8 weeks. And the lead time to replenish the regional DCs from the European DC is 3 days. What else do we know? I say the lot size in the EDC is on average 2 weeks. So that means I will order on average every 2 weeks. The lot size for the RDCs is 1 week, which means I replenish the RDCs on average 1 week. And last year I had 7 days of safety stock across the EDC and the RDCs. And now my CFO told me, well, you followed that multi-echelon webinar, so you seem to be much more educated on where to put safety stock. He says, okay, I will reduce the target from 7 days to 5 days. You now need to work with 5 days of safety stock. The target customer service level is 99%. And the final customer is delivered from the RDC. So we will assume that the customer is delivered from the RDCs. There is no customers which are being directly delivered from the EDC. And the question, I want to do a little poll here. The question I want you to answer is, how many days of safety stock do you want to keep centrally? So that's really the question I want to ask. And just to give an example, it could be that you say, okay, well, I want to keep 2 days of safety stock at the central DC. That will imply that you put 3 days of safety stock in the regional DC. If you say, I want to keep 4 days of safety stock at the central DC, it will allow you to put 1 day of safety stock in the regional DC. And the question we want you to answer is, how many of the 5 days do you want to keep centrally? And Cedric will start the poll now. So normally you should be seeing a screen here, and you can choose to either keep 0 days centrally, which means that you will put 5 days of safety stock in the regional DC, and the maximum you can keep centrally is 4. And so if you keep 4 days of safety stock at the central level, then you decide to put 1 day of safety stock at the regional DC. So we'll give you like 2-3 minutes to make up your mind and to give it a go. %74 voted, so I would say for the last ones, please make up your mind. We're at 82%. Okay, well, Cedric, can we show the result? Okay, so normally you should now see the result, right? So this is the result of the poll, and what we see here is that there seems to be a preference in the audience to keep 2 days of safety stock at the central DC, and for the rest, people seem to be a bit equal between 0, 1, 3, and 4, right? I will switch back to the presentation, if we may, Cedric. Let me show some of the results that I've seen in earlier games. So the results here were a bit different. There was clearly more people voting for the 2 option. These are some earlier results. So what do we see? I typically say, if you look at the graph on the left, the first thing which strikes me is that there seems to be no consensus, right? In our case, there was a slight preference to keep 2 days at the central level, but equally we had people who were keeping more of the safety stock at the central level. We also had people who were pushing more out. If we go to the right, these are the simulation results. So when I did my PhD, I did a lot of discrete event simulations, and these are the simulations for that specific example. So what do we see? We see that the service level towards the customer is increasing if we keep less days at the central DC. So basically, if I have less days at the central DC and I put more safety stock at the regional DC, I'm increasing the customer service level. I also see that there is different dots here. That's because not every simulation is exactly the same. So you can be lucky or you can have bad luck, but clearly there are better strategies and worse strategies. So pushing out the safety stock seems to be a better strategy in this example. So if I want to get rid of the variance here, I need to simulate over a longer period of time, and then we come to this type of result. So what do we see here? So we say, okay, if I want to get to 99% service towards the end customer, and the end customer is delivered from the regional DC, the only way to get there is to make sure that I put all of my safety stock at the RDC level. I need to put the 5 days at the RDC level. If I do the inverse, if I put all of my safety stock at the EDC level, I will have a good service from the EDC to the regional DC, but of course, then I will have no safety stock at the RDC level, which delivers a poor service level towards the final customer. So conclusion for this example is, for a fixed safety stock investment, strategies that put more safety stock in the market, they will provide a better customer service. And that's not very intuitive. I will come back to that. A different way to look at it is the following. So, okay, I can get to the 99% service by putting 0 safety stock at the EDC and 5 days at the regional DC. There are other ways to come to the same service level of 99%. The typical situation for companies to be in is shown here on the left. We've also shown in our polling result that we typically feel more comfortable if we have some safety stock at the central level and some safety stock closer to the customer at the regional level. So a typical situation for a company to be in is shown here on the left. I have a 99% service, but I do that with safety stock on the central DC and safety stock on the regional DC. Typically, I see that the central service level is lower than the service level in the market. Why? Well, because we understand that it's okay to have a 94% service here because we still have some safety stock in the market. I don't need 99% at the central level, right? If I add up, I will see that I get to 99%, but in total with 7 days of safety stock. The multi-echelon opportunity is to reduce from 7 days to 5 days, so I can reduce my safety stock with 2 out of 7. And 2 out of 7 is really 30%. And this is not just theory, this is also practice. So I can reduce my safety stock in the network with 30% while keeping the customer service level at 99%. Right? There's a lot more to say about that, like can my RDCs really accommodate this type of increase? And I will come to some of the typical pushbacks at the end of the presentation. But the results are there, and this is not just theory. We have also shown in practice that we can drive this type of safety stock improvements, first of all in the distribution network. But not only in the distribution network, we can do the same in this type of generic production distribution networks. And let's try to clarify also a little bit more on how that multi-echelon safety stock optimization works, right? Well, let's start with my safety stock of components here. right? So the typical situation to be in would be that we say, well, the production demands a very high availability of the components. Why? Because they want to be able to always immediately start production. They don't want to wait for the components. So that's why we need to have a lot of safety stock on the components. What happens if I reduce my safety stock of the components? Well, what I will see is that if I reduce my safety stock on the components, I will create a certain waiting time for my manufacturing, because I would like to start manufacturing the batteries, but I may not have all of the components available. So because I have a waiting time, the total lead time for the battery manufacturing is increasing. Not only do I have, let us say, the raw manufacturing time, I also need to include a waiting time for the components. As my total lead time for the manufacturing is increasing, I will need to increase my safety stocks on the bulk batteries if I want to keep my service level to the downstream operations. And then we can start over again. I can say, okay, what do I need for the packaging operation? I need packaging material and I need bulk batteries. The typical starting situation is that I will have a lot of safety stock for the packaging and a lot of safety stock for the bulk batteries. Why? Because the packaging operation doesn't want to wait. If I would reduce my safety stocks, or let's say the service levels on the packaging and on the bulk batteries, if I reduce the service levels on the packaging and the bulk batteries, I will again create a waiting time for the packaging operation. Now and then the packaging will have to wait for either packaging or bulk batteries to become available. Because that increases then the total lead time for the packaging operation, I will need to increase my safety stock if I want to keep the same service towards the next step in the supply chain, which are the regional DCs. And the last step we all more or less already explained, right? If I reduce my service level on the packaged SKUs centrally, that will reduce my safety stock. And if I want to keep the same service level towards the final customer, I will need to compensate for that by increasing the safety stocks in the regional DC. Well, let's see what multi-echelon optimization gives as a result for this type of battery supply chain. This is shown in the following slide. The green surface is what we typically see as the starting situation in companies. We will have safety stock across the supply chain, right? So I have safety stock of raw materials and packaging, safety stock of bulk, which is the intermediate, safety stock of the finished product at the central DC, and safety stock of the finished product at the regional DC. The authors give some cost information. So if you do the single echelon calculation where we put safety stock everywhere, the safety stock investment is 1.19 million. If we apply the multi-echelon optimization, what we see is that we will push all of the safety stock to the customer-facing echelon. At the customer-facing echelon, we face a significant increase. We need to increase from 0.2 to 0.34. So that's a 70% increase of safety stocks at the regional DC level. That's a significant increase. But if I look at the opportunity in the full supply chain, I see I can reduce the supply chain inventory, supply chain safety stock, from 1.19 million to 0.34. So that's a 70% reduction. That's a huge amount. And again, at the end of the presentation, I will try to explain some of the pushback we see in organizations. But in general, the principle is, the underlying principle is simple. It's the principle is risk pooling, and it says, okay, instead of duplicating safety stocks at every echelon, what I try to do is I try to aggregate the risks of different echelons onto one echelon. And if I need to choose one echelon, it's typically the customer-facing echelon, because there I need to put safety stock anyway, right? And does this work? Well, again, because people distrust the results. I have done extensive simulation testing in my PhD, and the simulated service level for this case was 96%, which is above the 95% target. So this really works. Again, this is also not theory. We have implemented this in practice, and we have really taken out $30 million of inventory for one of our customers in implementing this type of multi-echelon safety stock optimization. Okay, so that's a basic introduction into why do we hold inventory, what's the difference between single echelon and multi-echelon. We already drilled down on the safety stock aspect. I will now hand over to Sven, who will give a demo of the safety stock part, and then we will I will come back to explain also how this applies not only to safety stock but also to cycle stock. So I think on the one hand we now discussed how we can use multi-echelon safety stock optimization to identify significant inventory reduction potential. The next 5 minutes I also want to show that we have the same opportunity in cycle stock optimization, and I think that's an opportunity which is even less well known compared to the safety stock optimization. And I will again start by using a simple example, and it's this one. What I see in supply chains is that different steps in the supply chain will optimize their lot sizes, let us say one by one, and they will not take a multi-echelon perspective. And a commonly known approach might be the EOQ formula, where you say, okay, what is the cost of the product, what are the changeover costs, what's the demand rate, and if we use this linear supply chain as an example, we could come to the following result, where I say, okay, let's assume that each day I have a consumption of 1, so very simple demand. Because the upstream changeover costs are higher than the downstream changeover costs, I would typically see that, for instance, in my finishing operation, the lot size is 3, where, for instance, in the upstream operations, where the changeover costs are higher, maybe the EOQ result is 5. So let's face this type of example. Well, instead of just looking at it from a single echelon perspective and working with the 3 and 5, let's see what happens from the multi-echelon perspective. Well, the downstream inventory will be quite simple. I produce 3 and I consume 1 every day. So basically I will get this nice sawtooth pattern, which we know from the EOQ formula. If we see what is happening upstream, the pattern is quite different. Let's start over here. Well, I produce 5. And of the 5, 3 is consumed by the next step, by the downstream step, which leaves me with 2 left in inventory for at least 3 periods. Here I will get the next order at period 3. At the end of period 3, I will get the next order from the downstream stage. I have only 2 left, which means I will need to produce 5. But if I produce 5, my inventory will go to 7, of which I sell 3 to the downstream stage. So I will be left with an inventory of 4 during the next 3 periods. Then again I get an order of 3. I have 4, so I can deliver the 3. I will be left with 1 in inventory for 3 periods. Then I again need to produce 5. I go to 6, from which I sell 3, so I drop to 3. I keep the 3 for 3 periods. And then I'm left with 3, which I will sell off, and my inventory will be 0 for 3 periods. Well, we see that if we look at it from a multi-echelon perspective, I don't get a nice sawtooth. I really get a kind of pattern which is influenced by the downstream lot size. That's what changes in a multi-echelon perspective. Let's see what is the upstream inventory. Well, my average inventory is 0 for 3 periods. It's 1, it's 2, it's 3, and it's 4. So these are the different levels. So it's 0, 1, 2, 3, 4 divided by 5, which means that the average inventory upstream is 2. That's the average inventory I get. And notice that this inventory of 2 already assumes that there is some synchronization, that I'm able to produce exactly at the moment that the downstream stage will consume. That's already an assumption. Well, what I want to prove here is that I can increase the lot size and at the same time reduce the inventory. And that's very counterintuitive, because if that would be possible, the production manager will be happy, right? Increasing the lot size means bigger batches, which means less changeover costs and less capacity lost to changeovers. And if at the same time I can reduce the inventory, also the supply chain manager and the CFO will be happy. But that seems counterintuitive. Well, let's see what happens if I increase my lot size from 5 to 6. So this pattern here is the pattern we described with the lot size of 5. What happens if I increase my lot size to 6? Well, this is what happens. I produce 6, of which 3 is immediately consumed. I will keep 3 in inventory for 3 periods, and then the remaining 3 is consumed immediately, which gives me an inventory of 0. What is the average upstream inventory now? Well, the average upstream inventory is I carry 3, I carry 0, so 0 plus 3 divided by 2 is 1.5. So I've just proven that I have reduced my inventory by increasing the lot size. So we can decrease the cycle stock and decrease the changeover cost by increasing the upstream lot size, which seems counterintuitive. Decreasing the cycle stock from 2 to 1.5, that's a 25% reduction. And decrease the changeovers. So instead of having a changeover once every 5 periods, I now have a changeover once every 6 periods, which is a 70% reduction in changeover costs. And it also allows me to free up capacity by a 70% reduction in changeover time. So if this is in a bottleneck installation, it will be of a huge interest to the production manager and to the supply chain as a whole. Can we again apply this to a more generic production distribution network? The answer is yes. How does it work? Well, we will have some rules which say the upstream lot size in the optimal situation is an integer multiple of the downstream lot size. So if I distribute in a 2-weekly frequency, then I either package in a 2-weekly frequency or a 4-weekly frequency, right? Or vice versa. If I produce once every month, then typically I might, let's say, package here in a 2-weekly or a weekly frequency. That's how it works. A second thing we do is synchronize production and consumption by the following steps. So instead of having the reordering and the production desynchronized, we will try to make sure they are synchronized to the same moment in time. And we can optimize lot sizes. We can also optimize production frequencies. And if we do that, this is the type of result we get. You could say that I kind of have a distribution wheel. Some products I will distribute weekly. Other products I might distribute once every 2 weeks. Others I might distribute once every 4 weeks. I define the optimal packaging sequence, the optimal manufacturing sequence in the bulk battery. I make sure that when I manufacture the batteries in bulk, that part of it is immediately consumed by the packaging operation, and when the packaged SKUs are available, part of it is immediately shipped to the decentral DC. So I synchronize the timings and I try to synchronize the lot sizes. That's what I do. So I kind of put the whole network on a synchronized and optimal sequence. If you would do this, and again, these are the results for the battery supply chain, but we have also done that real life with some of our customers. Well, a basic starting point could be that we say, okay, well, you just use the same fixed frequency for all the steps. So everything needs to be weekly or everything needs to be monthly. If I switch to an EOQ principle where I say, well, I will optimize the lot size based on what's the changeover or ordering cost, what's the cost of the product, what's the demand, then probably that I will see that if I have less demand in a certain regional DC, I will ship less frequently. That would be the result of the EOQ optimization. That allows us to reduce already the cost with 12%. And here we talk about the combined ordering or changeover and inventory cost. We really look at the combination of the two. If we apply the multi-echelon lot sizing as we just described, we can halve the ordering and inventory cost. So we can significantly reduce the changeover cost, which frees up capacity, and at the same time we can lower the inventory, the cycle stock in the network. Right? So that's a second big opportunity we see in multi-echelon inventory optimization. Well, and what I wanted to say here is that we initially planned also a demo of the cycle stock part, but given the schedule, we didn't really have time. We will send out a short survey after the webinar. We will also see if there are people who are interested to also see a demo of the lot size optimization or the cycle stock optimization, which we would be more than happy to give in a follow-up webinar. So Cedric will take care of that. So, and the final point here is, well, if it is so promising, how come that many companies are still stuck in the single echelon and have not yet adopted the multi-echelon? Well, if I need to name 3 key challenges we see in implementation is, first of all, the results are counterintuitive. And we don't have the time to go into full detail, but well, pushing out safety stocks instead of centralizing, that simply seems counterintuitive. And the same holds for cycle stock, like decreasing the cycle stock by increasing the lot size. Well, it needs some time to adopt that new way of thinking. A second key issue I see is silo focus in organizations. If we think back about safety stock optimization, well, we can reduce the overall safety stock from 7 to 5, which is a 30% reduction. But as the regional DC manager, I will just see a significant increase. And I might not really trust that solution because the central DC is decreasing and I need to increase. And also the incentives might be functionally focused. If every echelon has its own incentive and everybody has his objective to reduce inventories, that might really, let us say, act as a big threshold to adopt that multi-echelon optimization. Another threshold might be you need more advanced tooling. So it's very hard to do this type of stuff with Excel. It's probably impossible. I've tried it and it clearly has its limits. So you need to go to more advanced tooling with more advanced algorithms, and it also risks becoming a black box. I've lived this topic for many years. I've spent part of my life in researching the method, so I really understand how they work, but it very easily becomes a black box. So certainly if you go for an advanced solution, also make sure that you don't buy a black box, but you look for a partner or an implementation partner who has a good knowledge on how this multi-echelon works, so that we can help to explain the counterintuitive aspects of the results, and that we can also help you with the change management, because if you can't really explain, people will just oppose and stick to the old way of working, the functional focus. So you need to be sure that you know how the algorithms really work, to be able to overcome that counterintuitive aspect, and also to make sure that you get that change management right. And don't, let's say, don't step too far, so crawl, walk, run. So there's a lot of value in just starting with a single echelon optimization. So if today you're not yet calculating your safety stocks based on a statistical formula, really start there, and you can do that with a single echelon focus. It will already give significant benefits. The next step could be like, how can I then optimize within the company boundaries, looking at the different stocks I have within the company. And the next step is then doing that across the chain. So if I'm delivering to key distributors or key customers, I might involve their inventories. I might also look at key suppliers and model their inventories, and then go for a multi-echelon optimization intercompany. And each of the steps is a next level of maturity, but the good thing is also that each of the steps has its own benefits. So let me pause here. That's basically what we had foreseen as content, and we're happy to get some of your questions. So we might not be able to answer all of them, but we might plan at least a follow-up meeting with the questions that you have been posting. So this is what you should normally see, and here you should be able to raise questions. So feel free, we have a couple of minutes left to shoot some questions. And I will at least already take one question which was raised earlier by one of the participants, and the question is this suitable for the FMCG market? And there's some clarification, like responsiveness in our organization is key, as is the fact that products expire. And well, my main answer to that would be, well, it's certainly suitable. And actually, I had a discussion with a major retailer last week where I told them, like, you have a lot of inventory sitting in the shops, you have a lot of inventory sitting in the central DC, you have a lot of inventory sitting at your suppliers, which could be an FMCG player. And it's clear that if you look at that end-to-end supply chain, you can hugely decrease the inventory in that supply chain. And what does that hold as an opportunity? Well, if I have less inventory in supply chain, it will also make that the product is more fresh when it is available to the customer. So it will also increase the shelf life available to the customer. But I see a key challenge there in trust, because not all of the retailers will put their full trust in their supplier, nor will there be a full trust between the central DC and the shops. Another question here, capacity constraints at the RDC. Well, good question. It's something that you need to model, so you need to check whether you can accommodate a stock increase. If that's not the case, if you don't have a necessary capacity, you can push some of the safety stock back upstream, but for sure the new paradigm will be that you will never get to a 95% service at the central DC. You may keep some safety stock, but only a little bit because you cannot fully accommodate. As for the optimization, is the obtained solution, is it optimal or is it approximated? Well, in the mathematical modeling, there are some approximations which are conservative, so the true optimum is even lower than we will calculate, but the good thing is that based on the approximations, we can easily come to an optimum solution for quite complex network. Another typical question I see here is, what if the landed cost at the RDC is much higher than the EDC? Very valid question. Well, if the downstream cost significantly increases, that would of course be a counter force, and a force which pushes the safety stock back upwards in the supply chain. But from the simulations we have seen, even if the cost increase is very significant, the risk pooling is more powerful. The new paradigm is that you don't want to duplicate safety stocks at each echelon. If you have a bad forecast and the product is very expensive downstream, well, the damage is already done. If you want to give a good service, you will need a lot of safety stock downstream. And as soon as you have a lot of safety stock downstream, that really acts as a magnet, and it will try to attract other risks in that supply chain. Maybe last question here. What about centralizing your slow-moving items and avoiding stocking them in all RDCs to avoid obsolescence creation? Very valid question, very valid remark. In general, the answer there is like, what we need to be aware is that if I centralize slow movers, it can increase the lead time to the customer. If I say I need to have my slow movers available within a 24-hour delivery time all over Europe, then I will need to keep stocks at the regional DCs. As soon as I keep stock at the regional DCs, that's where typically I will put all of the safety stock, even if the risk is higher. Of course, the question is, for these slow movers, do I need that 24-hour delivery time? Because if I could have a 1-week delivery time, I can shift the customer order decoupling point upstream and only put the safety stock at the central level. And if I can do it with only safety stock at the central level, I will be better off. But that's really a matter of what's the required lead time and what is the customer accepting as a lead time. So that's also a crucial element in that whole discussion. I see time is up, so we'll need to close the webinar here. We will take a careful look at your questions. We will make sure that we make a short follow-up and that we post some of the answers to the questions that you have been raising. Our team will also be reaching out to some of you, so if you would want to know more about some of the experience we have, if you have specific questions on how would this work in my specific environments with my specific constraints, we're more than happy to plan a follow-up call where we can go in more detail. But let me thank you all to participate in this webinar. The recording will be made available shortly, and also check out recordings of the earlier webinars we already did, and as I already mentioned, also in September we have a webinar which more in general will talk about inventory optimization, not necessarily the multi-echelon part. So thank you, and we'll hope to meet you back in one of our following webinars.